So I've been working on this and wanted to just run it by everybody while other people are showing up. Got our mastery policy URL, and this will push to gimbalabs.com right here. Just trying to figure out how to squeeze everything in. I'm not happy with the balance of components I'm getting right here. All this extra white space. What's up, Lucas? What's up, Nelson, Lewis? Hey, Curtis.
Hello from Lisbon.
Hey, hey. Word's getting out that you live in the next Silicon Valley.
Why is that? We're starting to pay tax now.
Well, I guess they're, you know, at a macro level, what's the impact of that?
Not sure. I'm sticking around for a while, but a bit offended, in air quotes, about the taxing. But let's see how it goes. It's fine. A seems to like it.
It's interesting. Did you grow up in Lisbon?
I'm actually like 1 hour away, like 40 minutes by train. So yeah, it's my hometown. It's Santarém. We actually have Santarém in Brazil as well. It's the same name of city. And I grew up here until my 30s, and I was in the UK for 3 years. Apart from that, I've always been here.
Hello, Mr. Juan. Hey, Marcia. Hey, well.
I'm really curious to explore the US as well.
Yeah, get over here. It's going to be fun to start having different sorts of meetings here and there.
Yeah.
So I dove in to the mastery policy stuff. We've been collecting notes here on the completion and contribution proposal. And one of the next steps was to just add a URL like this one to the metadata so we could explain what's going on. And it's actually provided me a really good chance to think about some other elements. How do we tell the story of PBL to the outside world? So one way to look at this that's starting to come together here is as marketing collateral. And this is a link that we'll be able to share. This is on my local host right now, but I pushed some changes to gimbalabs.com, and I'll push the most recent changes later today. But trying to tell the story, encouraging people to drop into Canvas. That's the best way to learn about the course, and that's the message we always want to send. But some people are going to want a quick overview. They're going to want to just know, hey, what does that metadata mean here, particularly the mastery levels bit? So I'm just trying to tell that story. This is not done. The balance, right, of just the spacing of these components is really not great. But the messaging is here. And then I still haven't drawn the connection of that this number here means that all these are completed. So there's a little bit more copy necessary, probably like right here. And then there's down here, you can go from 100, 200, and 300 level. Here's the 100 level modules, 200 and 300, with just a little bit of copy right here to kind of situate people, even bringing people into some pedagogy ideas, right? By linking to, here's a post about what student learning targets are. And Gimbal Labs is adopting this strategy that works for kids. We're bringing it to adults and using it to really kind of build up student ownership of what they're learning. So getting there on this, and I'm definitely open to feedback. Anybody have questions or anything that jumps off the page at you based on, you know, and again, you know, the context of this, right, is the work we've been doing here. And I just want to make sure that people are happy with what ends up here.
I think it's looking great personally. And it's since you've got it set up to a link, you know, as future versions of the course come out or everything, you know, all that kind of stuff, you know, it's adaptable without having to reissue anything or anything crazy. So I think it's looking awesome.
Thanks, Trevor. Yeah, I'm kind of envisioning like this will be the general mastery policies page, and then you'll have subsections or sublinks for particular courses. For now, there's just this one. But yeah, hopefully it's future compatible. So at a high level, I believe, Nelson, did you finish the course yesterday? Is that level 4 for everything?
Not yet. I haven't finished the 3024 one. I'm thinking on what should I make.
Awesome. Yeah, man. Thanks for submitting. So you got the first submission in for the 3034 playing with Plutus V2, and that's what we're going to look at today. And thanks for thinking creatively about that transaction component assignment. So we're really close to needing these course completion tokens because people are starting to finish the course. And I'm just really excited to have a public facing page like this out in the world, but also people starting to hold these course completion tokens and for us to be able to show that leads to contribution. I think the messaging that we're going to be able to share with the wider world is going to be really fun. It's going to be really exciting to get that out there. But then the other reason we were working on these tokens, and this was kind of part of the original proposal, why do we need to do this? Because the first instance of GBTE on mainnet is going to require this token. And after playing around with Plutus V2 last week and hearing updates from the Martify guys, I feel like it would be a little bit inefficient to like rush and have a Plutus V1 version of this deployed only to then redo it and redeploy a different version on V2 a couple days later. So I shared that note on Discord yesterday and just want to say it here. I think it's probably worth waiting to release this on mainnet until we have it working with the Plutus V2 contracts and the front end. But does that raise questions for anybody? Any objections to that approach?
Are you planning to create an assignment maybe where the students could potentially figure out how to convert it to a Plutus V2?
That's okay. That's a great question. So I think that needs to be part of the course in the future, right? So at some point, we should probably go back and recreate the always succeeds assignment to use Plutus V2 from the beginning. I don't think it's urgent to do that right away. I still think it's helpful for people to get a feeling for, okay, here's a script, here's how I use it, and then to introduce reference UTXOs. The Faucet project is a really cool example for seeing how V2 is different from V1, right? And if we could create an assignment that shows that you no longer have to submit a Git merge request to share your CBOR, but you can just share a reference UTXO. So having a Plutus V2 version of a Faucet could be a really cool thing to take on. And I'm kind of thinking ahead to building that module as a way for somebody maybe to contribute in the medium term, maybe like a month or two from now. This could be something that somebody who's been a student in this class, but maybe wants to start mentoring or contributing content. I think it would be really cool to have a bounty for writing a Canvas module and an assignment about taking the faucet to V2. When it comes to GBTE, that's already covered. So the if I go to modules and then 303, it's basically, providing the boilerplate here and just going through the process of building transactions. So almost to the step that you're talking about, Curtis, which is having people take something that's built on V1 and change it themselves. This is kind of an in-between point. It's saying, okay, here's a V2 version of something that you already know about. And your challenge is to work through some of these transactions right here that are provided. So some of it's the old way. In the README, you can do it this way. But then some scripts are provided to help people start, and anybody who's not writing scripts on their own already, these scripts will hold your hand a little bit and start to help you be comfortable with that. So kind of sorry for the long answer, but it's kind of like an in-between scenario. And I think there's room to continue thinking about that. Dagwell, what's going on? Are you in Denver yet?
Not quite yet. I'm gonna leave out tomorrow morning at 11. So we're so pumped. I know, bro. I know you met. I know Alpine was talking to you. Get that guy going and kind of see what we've been cooking. But I got a question, man. And I know it's a little selfish, but it's really quick. Can I get credit for the demo unlocking the CLI where we did that for one of my assignments? So I can kind of kill two birds with one stone.
Yeah, what assignment is that? I'll just write that down.
I think there is a master assignment like unlocking from the faucet, or it's an assignment.
Yeah. This plan with the pre-production thing. Did I miss you there?
Yeah, I don't know if I got it. I might not have, because I don't know if I think once I did it live, I was like, okay, I checked that off in my head. And when I went back to go do it, I think we had already updated the contract for that particular token, or we were in limbo or something. So I just wanted to touch back with that. I really appreciate you.
Yeah, let's just stick around for a second after this session and let's figure that out.
Sounds great. Thanks, man.
Cool. So we've got this context here. This is what we're building towards. I'll push some changes after I just play with this section a bit more. And I'll ask once again for feedback on the plan. And then the other thing we need is an assignment on Canvas that will be available to anybody who's completed the minimum requirements, where you can come and you can say, okay, mint me that course completion token. So I'll create that and share it later today. What I really wanted to focus on today is thinking about the Plutus part of GBTE. And if this video turns out to be a helpful resource, we can just add it to where you see 303 for this mastery level assignment. We can just add the video here, and this would support people to do this part. So I wanted, on the one hand, just to take a high level view of what's changing, to just expose people to this so we can all start to think about it together. And then, even more exciting than that, I want to think together about how we might use some of these new features to do things that we haven't quite been able to do yet. Let's start by just looking through the code here. Okay, so you can pull this. Note that this is a new repo. And I'm putting this link in the chat just in case anybody doesn't have it. And this is where the work for the Plutus GBTE contracts will live moving forward. Okay, there's no reason to keep building on Plutus V1. We have that as an example for people to learn about it. And like Curtis mentioned, there will be, certainly in the next major re-release of the course, Plutus V2 will be the starting point. But for now, the V1 version of this little DApp is still available for people to learn with. But when it comes to the real development work, this is where the action is going to happen. In the GBTE folder, we've got the compiler, the 2 different validators, and a types file. And a couple of things have been upgraded here. And so hopefully this syntax is starting to look familiar to people. You might have seen this for the first time when Mix was working through the 0-1 game. But this is a critical design pattern to understand. We have a parameterized redeemer here. There hasn't really been a dedicated lesson about this yet, but you got a little exposure to it in those 303 lectures. And this is something that I want to make sure people notice, and you can kind of see how it's different from the old version. It's similar to a parameterized validator. Right? With a validator, I have the option of adding a parameter right here, along with the typical arguments and typical inputs. And I can give that parameter a name, and then I can access it in my contract logic. In the very same way, with redeemers, I'm not limited to just using a word. And if I skip back to escrow for a second, right? In escrow, it's still just simple, what's my action? And these words are indexed, they're mapped to integers, right? 0, 1, 2 in the types file, and that's how we can reference them from the front end. But hopefully you can see how much more robust it is if, in addition to specifying an action, you can specify an action and some data to go along with it. And so this is all encapsulated in the treasury action type, which is defined here. Treasury action. It can either be commit with parameter, which is defined here, or it can be a simple word, manage. And even if we're using a parameterized redeemer, we can still map the action word to an integer, just like we've been doing before. Let me just pause there. That was kind of a lot of technical stuff. I'm sure some people have looked at this before, but maybe this is new to you. What questions do you have about parameterized redeemers? Yeah, Trevor.
Yeah, so this is something that actually relates to Plutus V1 as well that I was working with when I was doing the rock, paper, scissors variation of the 0-1 game in the previous version of Mastery Level 4. I noticed that Mix did in one of the lectures, the original file did not have the explicitly stated indexes like you have highlighted there. And I did not add them when I did the rock, paper, scissors game, but I also got an unexpected result where one player should have won and it said the other player did. And I'm wondering if you absolutely have to have the explicitly stated numbers for it to align the way you would expect. Does that question make sense?
Yes, it's a great question. I have the same one. I have also noticed that you can get contracts to work without this. And I've also noticed that that can lead to some surprising behavior. And I haven't like slowed down to really look at that behavior one by one to kind of figure out what exactly is going on. And that's made me kind of say, well, you know what? Yes, it's possible without this, but it just feels easier to include it. but I don't know what best practice is.
Sure.
Mix, yeah, how can you help us out with that part?
First, hello. About this, the problem is if you are not using the index, the explicit and very defined and deterministic index. If you are using Bluetooth version 1 or Bluetooth version 2, or maybe in future Bluetooth version 3, you might end up with different index for your redeemer. So for example, here commit is 0, manage is 1. Now it is Bluetooth version 2, fine. But if you are using Bluetooth version 3, or if someone else compiled it, as Laris was saying, this index might change. So commit become 1 or something else, and manage become something else. So
Wait, so he said, that's all he gave us though, is this might change, but not a rhyme or a reason as to why?
it might change based on the behavior of that function, because that function, if you have, do you have the Bluetooth documentation right now? Because I want to show you about this make is index. Make.
Hold on, there's a few different versions out there. Bluetooth make is index. I don't have it running right now.
Why it didn't show on the documentation?
It's that documentation's actually been a little weird lately. I think they have a few different versions running for some reason.
Oh, by the way, James, you need to go to the first page, because if you are searching now, you are searching in Ledger in this library. But if you go, that's the issue too. I mean, you do not search in whole library, whole Bluetooth.
I know I should be running this locally, but I'm not right now.
I think if you are removing on the URL, yeah, that would be better, because yeah.
Oh, here we go.
Here, if you search, I think it would tell you where is it.
It's Control S.
Control S.
Right now, you're looking only on this page. Control S will search all of
Oh,
this.
okay. Now
Yeah.
I can do it. Make
Yeah.
is indexed.
Yeah, exactly that one. And please click the source. The from source. So if you look at the unstable make is data, which as Tara said, why not using? It is using again same function, make is data index, but it takes the numbers from another function, which is default index. And default index, which defined above, is a start from 0. It's just a very simple. I mean, it doesn't look simple, but it is a simple set of numbers starting from 0 till infinity. So the problem is this function that's supposed to give you the indexes, and then by using the monad here between make is data index name and the monad and default index name, might have different behavior in different Bluetooth version. That's a problem. So for production level, you need, and actually it was advised on best practice, to do it by hand, manually. So using make is data index and manually, just like as James wrote it down here, commit 0, manage 1. So it's just for testing, go ahead with unstable, but for production, definitely we need to go with a stable one.
So, I mean, all in all, you could do without this, but why? Just if you can give yourself predictability and stability, might as well include make is data indexed.
Yeah, that helps a lot. Thanks, Mix. I know you kind of explained that in the lecture, but this kind of helped clarify it for me. I don't think it sunk in the first time. I appreciate it.
No, it's okay. It's okay. I'm sorry, I didn't explain it better in that lecture. Sorry.
Curtis, what do you say?
That's all super helpful. Actually, I have a couple questions because I'm not quite as far absorbing that. If you don't make his data indexed, how do you call, a commit, manage, update? How do you call it if it's not indexed?
It gets indexed by default.
Oh,
Like
okay. So,
you should remember by your mind that the order which you are making your business logic in validator is the same for the index. So the order that matters. But for example, another benefit of using make is data index, you can change that order. For example, James, would you please go to the validator? Same validator for escrow or anything, doesn't matter, for the commit.
Yeah, I'm gonna jump in here so it's easier to navigate. We can have a few
Oh.
things open. So here's the validator.
For example, here, yeah, exactly. The order, the Bluetooth compiler see that, okay, this is the first name, I'm getting the order. So this is a 0, manage is another one. I'm adding a 1. But if you go with make is data index, you can assign any index. So really, you can assign like 1,000 to one of them, and I don't know, 10,900,000,000 something to another, and it works. Doesn't there is no limitation. So you have the option for you have the flexibility to index all these without regarding to the order that you are writing.
So you could throw in arbitrary numbers here, and maybe that provides an extra level of just confusion to an attacker or something,
Yeah, but just by reverse engineering, which I showed you guys,
I know it doesn't really help.
Decoding CBOR, we can see all of these indexes. Yeah.
Might as well keep it simple for now. Curtis,
so
it sounds like there were a few things.
yeah, the second question is contextual. You've got multiple files. It's all one script. Where I'm lacking on understanding is I have a DApp, and let's say there's a minting policy to mint NFTs. There's an escrow to list those NFTs on some kind of marketplace. Maybe there's some other script. Those are all, different script purposes. Do they have to be independent script addresses, or can I create like a primary script that has like this, a minting function, and then it calls the minting script purpose, but it all falls under the single script address? Or how does that work?
Excellent. Well, and that question really gets us into, because with Plutus V2, we're now going to be talking about on-chain references to scripts in a few different ways, right? So with V1, it was just, okay, a Plutus script can give me a contract address. That's the contract address I need, but everything else, the CBOR, that's off-chain, and so I can pass that around. Now, we have one thing to distinguish between what a minting validator can do and it's a minting script. What's the right way to say it? You've got the minting purpose or the spending purpose for your validator, right? So we can call I tend to think of the spending validator as the default Plutus script, and then the minting validator as a minting script. So the words are always confusing, but at the end of the day, if I write a minting validator, that I'm not going to use that to generate an address. I'm going to use that to generate a minting policy. Whereas the spending validator, that's what's going to generate an address where we've been, for example, locking spendable UTXOs. So to combine a spending validator and a minting validator, I think those do stay as separate concerns. Because
Uh,
one is telling you the rules about when you can mint with that. Yeah, go ahead, go.
No, I'm just asking, is it possible to mix several script purposes to one validator? Because I think that the 4 different purposes we already have are very different. I haven't seen any things like mix.
They have different signatures in the first place. Right, so this is the type signature right here for a spending validator, but a minting validator only has a redeemer and context. It doesn't even consider datum.
Yeah. Even for a staking, you cannot mix a rewarding a script and certifying a script together. You have to have 2 different script for a staking and a smart contract. So I don't know if it's possible.
So each of those scripts then has its own rules. Now, both minting and spending scripts, I haven't tried it yet, but I'm assuming certifying and rewarding scripts as well can be posted on chain and consumed as reference scripts, right? So you can put a minting policy, or sorry, you can put the CBOR for a minting validator in a reference UTXO, and then you can use that reference to mint NFTs. And then you would need a different one for the spending part.
Okay, so they would be completely separate.
But a
Alright.
question, which address, I am asking the Curtis question furthermore, which address we should send that UTXO, which consists of minting a smart contract CBOR and a spending a script, or the same minting address? Although we don't use it, but for sake of using the smart contract on chain, should we use that, like sending a UTXO, that UTXO to that minting address, forgetting about it?
How are you defining minting address?
I think we can get that minting address out of the validator. I haven't tried, I don't know, but I think we can get, right? I don't know.
I remember I tried that before, and I'm pretty sure it's not possible, but it's probably worth trying again.
Can you not store it like you do in the constructor for the?
Let's just see what happens right here. Okay, so look, here's from early in the course. Here is the always. This is basically the always allows us to mint policy right here, and it's compiled here. And so we get the output, my minting script.plutus. The question is, can you make an address out of this Plutus script right here?
I don't see why we can't, because the address is a hash and we can get the hash of this Plutus and then turn it to the address by bake30.
Here's a hint, right? If I want to build an address, I have to supply. I can supply a payment script file or a stake script file, and let's see if it knows the difference. So I'm going to say
My guess is no. My guess is this will not work. Because I mean, if it doesn't allow for datum, that completely changes how the transaction is handled.
I think so too. Let's just copy this.
I think the file should be front of that switch.
Oh, you're right. That's my fault. There we go.
There's a typo in there too.
Where?
It's
Payment script
Yeah.
file.
I need more than a skipped. Here we go.
Yeah, maybe a
Oh,
coffee.
I gave me an address. That's the problem.
Yeah, because the policy has a payment. It has a payment escrow.
So
This-
imagine if you want to choose, I'm really asking, I mean, this is my question too. If you want to choose put in that UTXO, which has the minting Bluetooth spot contract, and you are going to use it for 10,000 different transactions, will you use this address and leave that, I don't know how much ADA and how much UTXO, that UTXO, living there forever, maybe as a evidence, I don't know, maybe as a something that's showing to people that, yeah, this was the on-chain evidence, or we will use it some other place that we can spend that UTXO after minting all those 10,000 NFTs, for example.
I would love to know how you spend, well, right, this one's always succeeds, but I'm very curious about how you would spend from this address.
We can't, I think. We cannot spend it. Because for a spending, we need, I don't know, maybe we can.
Yeah, there's a S key for the policy, and I don't know why you could just attach this script. I don't know though, just.
Right, you just throw, I mean, you would try to spend, so that's actually a fun, if anybody wants to do that exploration, give it a try. Try to build the address for this always mints script. Lock a UTXO there with, I mean, assume it's going to have some arbitrary datum on it. Just throw some datum on it and see if you can unlock it. I'd be curious to know.
But since we need Redeemer for spending, I think we cannot spend it. We don't have Redeemer. Or, oh, we have Redeemer. This is the Redeemer. This is not the data. Yeah.
Yeah.
So we can,
Gosh, well, you know, just when you think like this is the kind of thing that just makes it exposes how much there is to still know. Like, okay, sure, we got an address there, but there's more to test and try to understand that. That's really interesting.
There's also the question if that'll remain that way in V2, because this is a V1 script, right?
Mm-hmm. Mm-hmm. But in terms of design, I'm still convinced that it's worth it to break a DApp into its component contracts, right? There's logic for different sorts of interactions. And to me, it still feels good to separate that logic, but I'm definitely ready to be convinced otherwise as we keep discovering things here.
Okay, so separate the logic and they don't necessarily, and only integrate them if necessary. Is that what I'm hearing? So I have a minting, I have an escrow, try to keep them separate. They interact with these contracts separately unless I have a need otherwise.
but I think you have to connect somehow. I mean, for example, the policy ID of that contract minting to
Right.
another contract tool. So sure, it should be separated, but I think they should be interconnected somehow.
So I think this is a good example to think about what an alternative would be, right? In the case of GBTE here, treasury and escrow are kept as separate concerns and each can be interacted with, right? So I have a treasury where you can either make a claim and commit, or the issuer can manage it. We've got an escrow where each UTXO instance of a commitment can be either canceled, updated, or distributed. Could you combine all of this in one contract? I think so, right? By some clever use of complex redeemers, you could have a pool of funds stored at an address, and then when a commitment is made, the action is taken and a bounty UTXO is left at that same address. And I would be interested if if there were gains made on that approach in terms of usability or security. I like how clean it feels to have, okay, there's this address over here. That is the treasury. And we can take a snapshot of that address and we can see the state of that treasury right now. And then at this other address, we can see the status of all the open commitments.
Also, I think it would be cheaper because, for example, this it is for escrow. Why we need the treasury logic in it, which if a person wants to commit or redeem or whatever, they have to pay for treasury logics each and every time. Although we need just one time. I mean, like the usage of that logic is one time, but we have to pay it every single transaction because just we put everything in one contract.
Yeah.
I've been playing around with like kind of like a reverse validator, like using like a bash script on the front end to like filter UTXOs. And I find that, even you even have to like pay and make sure you have your UTXOs if you can't clear zero to even send change. So like little things like this, like we have to say, wait, like we have to make UTXO even to get back to change address. So interesting. So I'm really glad that Nick's brought up the cost aspect of it.
Yeah.
By the way, guys, have you tested that if you want to put this smart contract into a UTXO, what is the lowest possible ADA that must be inside that UTXO so can
yeah.
contain the whole smart contract? Have you tried that? Have you tested?
Yeah, I got some things for you on that. I just realized I'm running the wrong network right now to try a few things. Give me a second there. Yeah, I got some answers on that, and let's jump into that in just a moment. But going back to the concept of connecting contracts to each other, this is something I really want to highlight here for anybody who hasn't seen this yet. The escrow parameters and the treasury parameters are the same except for one thing, okay? In each case, we have to identify the token that's being used other than Lovelace in that system. We have to identify the policy ID of the contributor token. And that's the same in both cases. And we have to identify the pub key hash of some treasury issuer. Now, all of these, I think there are more decentralized options here, right? It would be great to be able to talk about multi-sig when we talk about treasury issuers. That's in the future. In fact, Kyle from Cardano Sharp is coming to show us some multi-sig tooling that his team built next Wednesday. So we've got a fun guest lecture next week. But this piece right here, if you haven't studied GBTE yet, when you do, pay close attention to this part. This hash right here is the hash of this validator. And in the treasury contract, you see how we have treasury param TP, and we've got this bounty contract hash parameter. Let's look for that. Bounty contract hash, okay? So this treasury can only interact with one instance of the escrow contract. And that's specified at compile time. And the treasury validator won't validate unless tokens are being sent to that particular instance of the escrow. And this is a design pattern that you can use in so many different ways to make sure that this or that contract is talking to another one. Just wanted to highlight that. Yeah, Trevor.
So I don't want to get too off topic here. If we want to cover this later, we can. But we were talking about kind of the structure of like, you know, two different contracts interacting with one another. You know, and you kind of covered how in GBTE, like there's, you know, a one-to-one relationship between the treasury and the escrow contracts, and explaining all that is great. But with this new V2, it brought up another question in my mind as far as, and I'm still just digging into this. I'm actually troubleshooting the new Plutus apps, but that's a whole nother story. But the issue of reference scripts being attached to UTXOs and where those are, and what the importance of the address that holds those is. It looks like in the example we have for Mastery 303 level 4, you set up a completely separate script to just hold reference UTXOs. And I can see why that would be wise to do, but I'm curious if that's necessary. If, for example, you could have a reference UTXO hosted at the wallet address or at the script address itself, or somewhere else. Obviously, you have the issue of a potential accidental spend, but I'm just kind of curious if that really matters, because it looks to me right now that you reference UTXO without needing anything from that address, any signing or anything like that. And I'm just trying to figure out where that fits in.
Yes, well, so yes, you've got it. Reference UTXOs can be at any address. It can be at any wallet address, any contract address. You know, and I set up a separate address for convenience, just to keep myself sane and know, okay, here's where all the reference scripts are. But that was a personal decision, and I'm curious what best practices are going to emerge. Curtis, you had something about that.
So I also played with that and found how easy it is to accidentally spend. I know you already mentioned that, Trevor, but it's definitely an issue. Reason being, say you put it in your wallet in just a normal payment PubKey hash wallet, and you have it inside the UTXO. If you interact with some contract with that wallet and spend your UTXOs, you know, the current library of the wallet interaction is just going to take, you know, a UTXO, consume it, give you the change address. So I actually did that, and it randomly selected the UTXO that had the reference script in it. It spent it, and then it sent it, you know, the reference script back into my wallet in a different UTXO. So now you have to update, you know, all your code that's pointing to that particular UTXO. So it seems like you could easily accidentally spend it, because from what I saw, Plutus Core doesn't know, right, the difference between these UTXOs and even script addresses. It doesn't know the difference between a native script address or a Plutus script address. So it just, it's very simple for a wallet balancing action or a Lovelace balancing action, transaction balancing, to consume that UTXO.
Hi, Curtis. So if I got it right, I heard you say like it gave you a different UTXO, but the reference script is still attached to it. Like, is that the case?
Sorry, wrong button. So in my case, yeah, I didn't try to interact with it when it came back into my wallet, but it was under a different UTXO. And I could see that because of the, when I queried, right, my UTXOs, I could see that it was there. And then the script was inside a new UTXO, and it had a new transaction hash and index. So when we try to reference that script, the old reference no longer works. You'll need a new reference. So it did come back, and I did see it present in the UTXO. I didn't try to interact with it a second time, unfortunately.
But Curtis, by saying that you need to change the code, did you specify that UTXO transaction ID or hash inside the contract? So that contract only accept that UTXO as a reference or something?
No, that's more like if you're using a front end or you have, maybe you're using Haskell off-chain code to build and compose the transaction, right? Your code, your backend code is going to have that reference UTXO somewhere hard-coded.
Yeah.
Right? You're not querying for that UTXO, you're hard coding that UTXO. So that is what needs to be changed.
But as I think Dagwell said, maybe we can do it on datum or some identification by datum. So do you think, is it possible to query a field in that datum to find that correct UTXO, which consists the correct smart contract? Or since the datum is changeable, it's not possible? I don't know.
That's a great use case. I'd love to, explore that as well. What happens if somebody enters the same datum on another, just coincidentally? There's two UTXOs with the same datum. Is that even possible? I imagine it would be, right?
Oh, yeah.
Yeah, it is
So
possible.
what would happen? What would happen in the results? You would have to pick and choose which one.
You'd have to have that UTXO in the transaction, right?
Yeah, if it's there, I think especially in these early days, there's going to be a lot of cases where people create reference UTXOs that point to the same datum or the same script. How many people do you think have deployed always succeeds Plutus v2 onto preprod, for example, right? There's probably a bunch of different reference UTXOs floating around. And maybe there's a good argument for that redundancy, right? If you want to use one of these reference UTXOs, you're trusting the person who put it there to leave it there. And Mix, to tie this back to your earlier question, the minimum, the min UTXO for these ones that actually hold real Plutus scripts is in the 18 to 21 ADA range.
Wow. That's a lot.
Yeah, wrap your mind around that for a second. Well, it is a lot, but if ADA is a utility, and that's the cost of putting a contract reference on chain, and you recoup those expenses after you use it a certain number of times, and you can unlock it anytime, and you could stake that ADA, right? It can just be in a staked wallet. These are really interesting new implications in my mind.
But so we cannot go under this. So for example, if we go, we get error of some UTXO minimum something on CLI, right?
Yeah, I can show you that. We can do that together in just a sec. Yeah.
That's a lot.
Dagwell, what do you think? It's interesting, isn't it?
It's so interesting. And I was wondering if we put an inline or if we put an embedded datum on the contract in the first place, shouldn't that prevent the wallet from accidentally spinning it?
Ooh, interesting. So you can throw datum on any UTXO. But this is different. So inline datum is different than a datum hash in that it's really just meant to be referenced. And so this UTXO right here that has this inline datum,
could you manually put one on there?
Yeah, this could just be spent. You could just spend this without referencing anything about datum. It can just be spent, because this serves a different purpose than a datum hash that would prevent you from unlocking a UTXO at a contract.
Got you. Could we add just a datum hash onto that UTXO after we create the contract, therefore rendering it unspendable?
Can we include a datum hash and an inline datum on a UTXO at a contract address to make sure that datum stays locked up? That's a good question.
But if the person has the datum to send it as an inline, so he can or she has the access to hash too. If the datum is correct, So the hash is correct too. I mean, I don't get that how someone has the access to inline data, but doesn't have access to a hash of that.
I'm just wondering if the wallet itself, like when the wallet is how the wallet chooses UTXOs based on value of UTXO for the transaction, if it would like, oh, I can't choose that one, it's got a datum lock on it, or you know, if it would be,
Okay, well, this goes back to Trevor's question, right? Like, why would I maybe want to have a separate address for all my reference UTXOs, right? And I have a feeling that devs are going to want to just create their own addresses, at least for when you're in the stage of playing around with reference scripts, right? To get a feeling for it. And then in production, I think there's going to be interesting new models. I think a lot, we've heard it here from a few of us, and I've heard it out there in the world, like the idea of locking a UTXO unspendably at a contract address just to ensure that that Plutus script will always be available. I think there's a compelling reason to consider that. And then there should also be, we should think about, hey, at what point do you decide that that's a necessary step? Because it's not every time.
James, can I ask a question about this reference address? You are saying that this 18 ADA, the first UTXO, is the one that holds the smart contract CBOR, right? I mean, this is the one.
Yeah,
The
let's go a little deeper into this. So I felt silly when I finally decided, oh, right, you can get the out file for your UTXO query. And you always want to do this when you're really automating things. If, you know, I think that's a good exercise for people to automate some scripts maybe that take the data from this out file. But let's just look at this out file for a second. At the reference address, I can query the UTXOs just like I did right here, but put the results in a file. And those results look like this. This is much more interesting than it used to be. It used to be just address, datum, and value. Now here we are with scripts, okay? So a few things to notice here. First of all, here's that first one with the 18.6 ADA in it, and this is what it looks like. So yeah, it's not visible on the quick view that Cardano CLI provides, but this is absolutely part of the UTXO. There's this reference script object that has an object inside called script, and you can see that the CBOR hex is supplied. So that's what's living on chain.
This doesn't have datum, but we can expand it.
Right, okay. So this is a critical distinction. This is not a UTXO at the contract that interacts with this script. This is just a reference to the CBOR for interacting with something at the actual address that's related to this script, right? And so in just a moment, let's look at how to use this thing. But I just want everybody to notice, first and foremost, the CBOR that you're familiar with, the same CBOR that maybe we've already been passing back and forth via GitLab, now it's on chain. Here it is. Okay, so there's this, for me, really demystified how a reference UTXO works. Oh, it just means that CBOR is on chain. Beautiful. Yeah, Nelson.
Yeah, I was just thinking that we have a record of all of the UTXOs that have been created, right? So even if we spent the reference UTXO, like, don't we have a record of it existing in the chain?
That's a good question too. Right. Historically, there is a record of this on chain. And so we should be able to go back into like DB Sync, for example, and find this script, meaning potentially that maybe I don't have to have a currently existing UTXO as reference. As far as I know, nobody's built that option yet. right? The way that Cardano CLI works now is you still have to have the live UTXO that can be referenced. But I feel like that's a really interesting thing to work on. Yeah, this was on chain at one point. It must still be there somewhere. How do we reference that? Curtis.
So yeah, that was the same question I had, and James, you answered it with basically the same thing, like try it out. So I did, and I could not reference that script. That was the same question I had. Okay, it's just CBOR that lives on hash. Just because you've spent the UTXO doesn't mean it doesn't live on chain anymore. It's still there. You can still query for the CBOR. So my question was the same thing, was why can't I just reference that CBOR that still lives on chain? It's just that the UTXO that was holding it is gone, and then execute that. But no, you can't. And I think that's just due to the principles of consuming, inputs and outputs such that you can query the data, but you can't execute the logic behind it without it being captured inside of a spendable object. So that's just kind of my understanding.
I wonder if it has something to do with like a hereafter, like if you burn that, it puts like it's no longer valid, kind of in a slot.
I mean, I guess it's protocol designed to say that you got to access this via a live transaction hash on the one hand. And then, but the simple fact is, eventually somebody's going to be able to create a query that looks at DB Sync, or, via GraphQL, you're able to grab this information and use it in a transaction. I'm certain somebody's thinking about that. It'd be really interesting to dive into. Mix, what do you think?
Before this hard fork, we already had the CBOR on a smart contract on DB Sync already.
That's true
But
too. That's true.
we couldn't get it, like we couldn't
Right.
query it, sure, right?
Right. That's
Even
right.
if, although I don't know, if someone runs the whole DB Sync in his system, can he get that from the DB Sync or not? I mean, not like us just with simple query getting that. But if a person run the whole database, maybe he can get it. But another thing, imagine this exists because we have the on-chain, we have two parts. One of them is Ledger, one of them is DB Sync. Now this CBOR now exists and live on Ledger. Imagine after consuming this UTXO, this exists again. After several, I think maybe months, we will have a very big ledger. And right now, wallets or something like Daedalus gets so hard to get syncs with network. So I think that was the good choice. So if you spend UTXO that consists of CBOR, it will burn, or somehow it will get just a very simple hash, and you don't have anything inside that old UTXO anymore, because you consume it and produce a just simple hash.
Wow.
And that hash will go to Ledger as a record. But after that, the new UTXO doesn't have CBOR, and maybe it's has some token or whatever. So I'm thinking if they didn't do this, if that CBOR again exists in Ledger and all these smart contract, after sometimes we would have very big and large ledger, like maybe terabyte or something, right?
It's going to get big. Yep. Yeah. Dagwell.
So all the V2 scripts that leave our CBOR on chain, I was wondering, do you think that we could use extract the CBOR and use the V1 Plutus submission technique and procedure to still validate the transaction?
That's the question. Yeah, I think that's a question that could definitely inspire some tinkering. And
Yeah, it's possible. I did it.
you did it, okay. Because so here, right, this is that
Well, thank you.
transaction hash that we were just looking at. It's timestamped from earlier in this week, and even when this UTXO with the script is spent, there's still going to be this indication that there's a Plutus V2 script. Cardano Scan's able to show this to us. And this reference right here isn't depending on, right? Like that information is here. So just to separate this question into two parts, the first question is, hey, isn't that CBOR still going to be on chain? And the answer is absolutely. The script right here, 591033, etc. That's exactly what we're looking at right here. So there is no doubt that this CBOR is on chain. And then, like Mix pointed out, it was as well for Plutus V1. You could go back and look at it. The question is more, okay, is the protocol designed so that I can consume that in a way that means I wouldn't have to attach that in some other way? And currently, my understanding is that there is not a way for that, and it's in the best interest, I think, of the protocol to, for it to take network tokens to be able to get this utility out of the protocol. But again, that doesn't stop everybody from hacking around and seeing, well, is there a way we can use this information that is on chain even after these UTXOs are spent to get that functionality?
Maybe I missed the part, but I mean, why wouldn't you be able to? It sounded like you said you shouldn't or couldn't.
So thinking from a protocol as public utility perspective, everybody with a stake in this protocol has a justifiable interest in the cost of using the protocol being fair and commensurate with the utility being gained. And so if at the Cardano protocol design level, it's impossible to consume this CBOR if it's not attached to a UTXO, or it's part of if it's not in a referenceable live UTXO, or if it's not attached to a transaction. To be unable to do that, I can see a justification for that. And to what it appears to me, this is not a matter of something that's technically infeasible. It's a matter of something that has been, I believe, rightfully prevented at the protocol design layer.
Okay, so I was actually mixing two concepts. What I meant was, like, why couldn't somebody query this, grab the CBOR hex, create a UTXO with a reference script using the same exact CBOR and try to execute it? So say the DApp owner closed down, spent the script that lived inside of a UTXO, it no longer technically exists on chain. You can throw it back on chain and try to validate it.
Right. Oh,
however,
totally.
it would still be the same validate.
Yes, of course. Well, so the one thing you'd want to check there, does this right here match precisely the CBOR that's spit out by my Plutus compiler, right? That's an easy thing just to double check on, and assuming they are indeed the same, then of course, anybody, anytime can say, oh, the reference script I was referring to got spent by whoever was supporting it. I'm going to grab that CBOR and I'm going to make a new reference UTXO so I can continue to have that utility, right? And that would be only in the case of a closed source project. Would you even want that option? In an open source project, you could just grab the repo, right, and get the CBOR yourself. So I guess, Curtis, what you're describing is a really good backdoor to some functionality for maybe some closed source Plutus functionality. Mix, what do you think?
I just wanted to add that if another person wants to add some maybe malicious CBOR or try to convince the DApp that this is the correct UTXO, I think by adding the a function that checks the hash of that CBOR resist inside the UTXO, we can prevent that. So instead of hard coding that, we can just hard code the hash of CBOR. So any UTXO that has that CBOR code, that Bluetooth code, and produce same hash, which we know that the hash is correct because the CBOR is correct, then we can be sure that if doesn't matter who built that UTXO is workable and it is trusted by the DApp. I think, do you think that's possible? Is it okay? A solution for using different UTXO, but same CBOR, and we can make sure that we are getting the exact correct CBOR just by taking the hash of CBOR. I don't know if
Do you think
it's
that's
happen. I don't know if it is possible on validator. I think I'm pretty sure it is happen. It is possible on off-chain code, at least in Haskell.
So, I mean, when I was a kid, the cops used to come to school to tell us, don't talk to strangers and don't do drugs, right? But like in the future, we're going to have to teach children not to use a stranger's UTXO. And just, you got to trust the source in some sense. If it's you, okay, good, you can trust that. But yeah, nobody should be going out and blindly using a reference UTXO from somebody they haven't verified.
But we can go with the code is law. So if the code is said this is correct, while, for example, in this case, the hash, we can trust it. Since I think the blockchain, the whole concept of blockchain is something like trustless, permissionless.
Yeah, don't
Why
trust,
not
verify.
going with, we trust the code, but yeah, the code goes with the logic. So just the hash, if the hash is correct, doesn't matter what UTXO it is.
Right on. So this is all about what do you gain, right? And so Sarah just asked the question in the chat, can't the reference script be put on a side chain? A lot of what we're learning here will apply exactly when we start thinking about Hydra, when Cardano copies start popping up, like SharesLake is already doing, using the Cardano protocol, but running a separate chain with that software. You know, there's a lot more possibilities for what can be done here. This is just data. The other question that a few people have had, well, isn't this a lot to put on chain? We don't know. I'm not aware of anything quite like this. So is this more data than an address or a datum hash? It certainly is. Is it worth the utility in the long run? Is it gonna scale or is it gonna bog down the chain? We don't know. We have to see it in practice. I'm really curious about that. Hey, I'll follow up with you on SharesLake, but you can look that up too. All right, so another thing to notice here. So there we go, reference scripts. They are part of the UTXOs. Here they are. This raises all sorts of new questions, some of which I think some people here will be inspired to follow through with these concepts. Make sure you do. I have some of those same questions, and I give myself a little bit of time every day to test out each one of them and try to get to the bottom of it. The other thing to notice here, look at this UTXO. This is actually the same hash with the next index because these both came from the same transaction. This one has inline datum and it looks a little bit illegible, right? From the CLI view, but I'm going to scroll down to this UTXO. This is BBB8 number 2, which is below. And when I do, look at how friendly that inline datum looks. This is exactly the format that hopefully you've been getting used to if you've been using datum from the CLI, or even this is the format that Mesh is going to compile us down to so that we can use it. So I just wanted to make sure people see that, and hopefully this is going to alleviate some of the mystery of what's going on with reference UTXOs. Now this hash right here is exactly the hash I would get if I just ran on CLI the hash datum function. But to my experiments thus far, unlocking is different. Okay, so here's one thing I tried, but it didn't work for me. I had a UTXO that had a datum hash attached to it. And then I had this UTXO right here with the inline datum. And I was not able to use the reference UTXO with inline datum to unlock a UTXO at a contract address that had the same hash attached to it. That doesn't mean it's not possible, but that's an example of a question that I had, and I did a little bit of research on it. Not enough to be certain that I've tried every permutation of putting those things together. But I just wanted to share that as an example. So there's our inline datum. And these ones, you see right here, what I was doing when I tested this out is just throwing 2 ADA on each reference UTXO. In the case of inline datum, that was sufficient. But in the case of reference scripts, I got an error that said it's not. Okay, so if I'd be happy to look at that for a few minutes if you guys want to see that error. But anybody else have questions before we jump to that? So in the repo, there's a scripts directory. And here's oh, no, sorry. Okay. In the repo, there is a scripts directory, and all you have to do to use these is just make sure to change some of these paths, make sure you have the right redeemer values, and you can play around with it. But when it comes to building reference UTXOs, I didn't bother writing scripts for that because you're not going to be, you have to create a reference UTXO once. So I'm sure there's some process that you'll want to automate at some point, but I just didn't bother doing that yet. Instead, I documented it in the README. And so creating a reference UTXO, and this transaction that I'm going to show you also creates a datum reference UTXO. It's going to do both. And so at a really high level, here's what it looks like, right? You simply say, okay, I'm going to send to some address. As we discussed earlier, it could be any address. For usability and for my own sanity, I chose to create a separate address, right? And then I try to send just 2 ADA with each of those UTXOs. With this one, I specify TX out reference script file and which file. For this one, TX out inline datum file and the path to the file. In the very same transaction, I'm also locking some funds at the new treasury address. And even though this bit right here and this bit right here, nope, just not even that part, just these 2 lines, right? These 2 lines right here and these 2 lines right here, they're talking about the same contract, but they don't have to be part of the same transaction. And there's a further example down below of just building out the reference script, the reference UTXO for the escrow contract. And look at how simple this transaction is. All it says is, look, grab any TX in, any UTXO that just has some ADA in it, and send to the reference address whatever script file you want to. Right, so this is the simplest transaction I could come up with for creating a reference script file. Let's see what happens if we try to run this thing with not enough ADA, just so we can look at that error. So what I'm going to do is I'm going to grab the escrow script right here, copy that tab. And let's put that here. Escrow script file. Then what else do we need? We need a UTXO and we need a reference address. There's a script provided just for querying your contracts, and so that's what I have right here. The reference address I'm going to use is this one. I think I called it ref UTXO address, and I'll just change it if not. Ref. So I won't push these changes. I'm just doing this as an example. We've got the escrow Plutus script, and then we need a TX in. Escrow script file. For the TX in, I'm just going to use a UTXO that has a bunch of ADA in it. Which one has a lot? This one has plenty. So now I should be able to grab sorry, it's getting a little buggy. I should be able just to grab this and try to build this transaction. What did I forget? Invalid argument. UTXO address. Weird. Try it again. Not sure why that didn't work that time. Was did I do the TX in row? Well, gosh, I don't know what's going wrong here. Anybody got better eyes? That looks good. That's what I wanted to say. What am I missing? Ref UTXO, that escrow.
That send the James, the change address is same. Is it?
Yeah, that's just, I don't have the escrow Plutus script set right. That's one. Oh, that's something else. Let's just grab this one again. Let's try that. There we go. Oh, no, that's not why. Here, let's just fix that. That's what we're looking for.
So 2 ADA was enough?
2 ADA, it says not enough. Min UTXO threshold not met for this output. Min required right here.
Wow. And I really I wonder that how this is related to the size of the CBOR, the size of the spot contract. I mean, this is considering the size, the step execution, all of these really worth 20 something ADA. So, I mean,
Or is that just a deterministic value that would be the same anytime you did that script? That's what I was wondering.
It's deterministic. Watch. It's if I use, let's just grab this minting, this always mints Plutus script right here that we looked at earlier. Let's make the escrow, I'm just going to use this variable because it's already there, to be this smaller file. And then let's run the same thing. And you can see I get the same
8
error,
ADA.
but it's much lower. Yeah, only almost 9 ADA instead of more than 20 ADA.
Maybe
So-
they add this for somehow civil attack, like if someone's try to pollute the ledger with so many CBOR. So maybe this expensive amount of Lovelace is a way to prevent someone's to, pollute and give a lot of UTXO with CBOR. This
I
will
think that's exactly right. You have to do that, right? I've been thinking about this number right here. And I think this is the most I've ever understood ADA as a utility, right? And why do we have native assets? ADA is not supposed to be money. It's supposed to be the network utility, and it's going to be used to open up a Hydra head and get that functionality. It's going to be used to ensure that you have access to this or that contract in the future. You need money, make your own token for that, right? But ADA is really it's the network utility token.
By the way, James, this amount is kind of same on mainnet, or it is
That's
different?
also right. So all of these numbers are hearsay until we see what they are on mainnet. I haven't tested that yet. I've kind of been assuming they're the same because the protocol parameters are the same, but we'll find out really soon.
So have you guys tried to use inline datum inside your contract, inside the validator?
Yeah.
Or have you tried that only on off-chain code?
This
Haskell off-chain.
I got all of these transactions working. So if you keep going, I just showed you that reference transaction, but the scripts provided here. Here is a bounty commitment. And what it's going to look like to make a bounty commitment. We have to unlock funds from the treasury. We have to place those funds at an escrow address. And you can see in all cases, both the reference that allows me to unlock the contract is an inline datum file. We say that there is a reference script for this. oops, no, this is the whole thing. Here's the UTXO in the treasury. Here's the UTXO that has the Plutus CBOR in it. Here's just, we have to specify the version. This is kind of forward looking and knowing that there'll be versions 3 and beyond. And then we're using inline. Actually, no, we're using, this is not inline datum right here. This is what we need. We need to change the way we say that we have datum when you're using a reference UTXO. That's what this first bit is. But then this is an example of, we have inline datum right here. And everything works. I did a few full laps with all of this, and it's all working. And hopefully this script just makes it easier for people to mess around. It's not fully automated. It's still going to make you choose your UTXOs. I want people to be hands-on with this still. But hopefully if you work through these scripts, it'll help you get your mind around some of these things.
So for the next transaction, can we use this inline datum as a reference TX in datum? I don't know, something after that. I don't know.
Well, okay,
switches.
this, and I want to really talk about that question tomorrow. In this case, you don't have to, because look right here, you just say, hey, that inline datum is already on the
I see.
UTXO at the
Great,
contract
great.
address. You just say, hey, it's already there, right? Boom. And so that's beautiful. That's really convenient.
Yeah.
Where it gets interesting is when we want to use some independent datum that's stored in some other UTXO to inform the use of a smart contract. And I have a use case in mind for that. Nelson, what do you think?
Oh, I had a very specific question now that we're here. For the Treasury XM file, I kind of I saw a sort of nested datum. I think I haven't seen it before. Just I was going to say.
Yeah, dude. Okay. Remember, okay, at the beginning, that takes us full circle back to parameterized redeemers. Okay, and so the question is, look, it's easy. If all I have is a word like manage or distribute, the redeemer for that is simple. And in the case of datum, it's also relatively simple. This format, I hope this is starting to look familiar to folks, right? You've got the constructor and you've got your array of fields. But how do I combine those things? And this is an example of that. So this is what the redeemer file looks like for committing to a bounty. Commit B. Let me jump over to types for a second. Remember, first of all, that the index for commit is 0. And then the B is bounty details, which have these fields as defined here. So this 0 right here maps to, oh, did it close? Maps to this 0 right here. And then the parameter of that redeemer is this whole fields bit right here, except that it has another constructor. This being the automatically mapped 0 that maps to this bounty details, okay? Right, we don't have any make data is indexed for bounty details, but since it's the only option, it's automatically given that constructor 0 and then the fields inside. So this is just extending the design pattern that you've already started to see into the world of parameterized redeemers, where we can have actions denoted by indexed numbers, and then data to support each of those indexes looking like this.
So this works in V1 also, or is it only V2?
It does, yeah. We never used this design pattern in V1, except for, well, Mix used it in the 0-1 game, right? But this is a place we really want to get to, and so this felt like a good chance to kind of move this direction. It was necessary for GBTE anyway, so.
And in my opinion, it would be necessary for future users because as we are going, more information becoming public. Your datum is public now. All the CBOR was public. So you cannot rely on the datum about like I have the datum, everyone have just hashes. No, now you have to use and you have to somehow broadcast your datum, all the structure with data. Sure, there are functions like SHA to encrypt it, but now the only option you have to secure your contracts is parameters of your redeemers. And also how to interconnect or interact the datum and redeemer together, which I think you guys saw in 0-1 game. But I hope in future, in next iteration, I will create the on-chain voting out of that because it is possible.
Yes.
It is possible on-chain voting based on that SHA and the datum. So the vote would be encrypted, and based on the encrypted vote, which user are producing and consume the data, consume the UTXO, produce a new UTXO and add in new votes. And then at the end, the redeemer gets the vote, doing some calculation, and voila, you have the end result. So, but right now, no, I mean, it's already complicated. But my question is, James, about the fourth assignment, the mastery. Now the students should do what exactly? Because the code is already here.
Right.
The script.
Yeah. So in this case, and maybe in the long run, we might decide that this is not a high enough standard. But I would like to test this and see. Last week we talked a little bit about, is the bar too high for getting a course completion token, right? And there's two things we want to balance. If people participate in something, it shouldn't be impossible to get a credential token, while on the same hand, that token has to mean something, right? I hope when people earn one, they can actually do some things. So this module is about business logic in Plutus validators. And the simple fact is, we're not asking students to write a lot of their own business logic, not yet. And so maybe we're going to want a higher standard in the future. But for now, if people demonstrate mastery by just taking these contracts for a full spin, making sure they're able to run them, I want to see if that's enough for us to then say, okay, now that you've done that, come out over here. Let's start contributing to something. And at the contribute stage, we will have people writing original Plutus or extending the contracts if that's the way we want to go.
I see.
Yeah, for me, completion for this one, it was pretty similar with 303 too, right? So
Yeah.
it's basically just like I had a lot of questions that was inside the code, but just following the instructions and completing the assignment, it wasn't that much of a task.
Maybe not, right. So maybe not sufficient to say that somebody has mastered Plutus, right? But on the very same hand, at this moment in time, people have to understand what the components of a Plutus V2 transaction are. And so emphasizing that for now, with full recognition that in the long term, this is probably not a high enough bar. I think it's better to start here get people this far, then yeah, if a bunch of people say, hey, look, like, we need to know more Plutus to talk about getting a course completion token, let's build that out as we move forward.
But I think, James, you made it very cleverly. I don't know if you did it on purpose on this fourth assignment, that the finishing the assignment is not the point, although it might be simple. But the question that rise, as the Nelson says, that's the whole point of that assignment. So if you finish that, good, nice. But if you don't have the question and you just did that, I think you failed that assignment. But if, like Nelson, you got lots of questions, I think you succeed that assignment.
Yes. If you have questions, things are going right. And we're
Yeah.
about to start, this is still a pioneer cohort for this course, right? We don't have any data yet that says, hey, this course actually helps people become contributors. We just don't have it yet. So what's the only thing to do? Start working. Let's build up that data. Let's see what happens. And if 10 out of 10 people who earn a course completion token also then have a track record of finishing early bounties, that's great. If 10 out of 10 get the course completion token and no bounties ever get done, all right, well, we're gonna have some serious questions for this whole way of doing things, right? But we just need to see it. We need to see what happens first. And I'm hoping that it'll be really interesting also to then look at what kind of bounties people take on. Hey, are people only doing the front end bounties? Are people taking on the Plutus ones? Are they doing it successfully? All of that, there's a lot of speculation you could do, but I'm not really about speculating. I want to just see what happens. And so that's what I think that's in all of our best interest, to look at that closely, see what happens, look at the real discrepancy between some desired state and the data that we're seeing, and then talk about what to adjust. Yeah, Nelson.
Yeah, one thing I wanted to suggest was for a live coding session to be going through the IOHK tutorial in GitHub that you have put the link in the repo for this
Yeah.
V2. Like I think that should exist out there in the world. Like if we can do a tutorial on what they mean by those documentation, and maybe we can show it in a transaction. We can do I think it will help a lot of people. And I think even if we're putting up the video on Google, YouTube, then I think it's a good resource, I think.
That's great. Yeah, so this link right here, this is what I worked through to kind of build these docs out. Yeah, should we just do a live coding session? Maybe we do this tomorrow. Just work through this in order. Understand this step by step and see how much makes sense, because this transaction has a few different things going on. It's got staking script, it's got a minting script. Yeah, we could work through this. Would anybody be willing to drive that one? I'm kind of tired of my own voice, and I would love to see other people kind of practicing, being in charge of running through stuff. So if anybody wants to step up for that, just say so right now, or say so in Discord. The other thing I was hoping to look at together, Mix mentioned a few minutes ago regarding inline datum and datum that exists separately from a contract, but is used in a contract. And I just want to plant one seed in everybody's head before we close up for today. So the current Treasury validator validates as long as some some bounty constraints are being met. Specifically, the redeemer that's being used to make a commitment, which is also going to be the datum that heads over to the escrow. Those values are going to match, and the values in this transaction have to match what's in that redeemer. Fine. But this is not really secure, because even though it's gated by an access token, and so all of us, you know, if in these early days, I've talked about this previously, we're relying on the high trust of who has these initial access tokens to test out the system and to build it. But in order for it to scale, we need a more robust solution than that. So here's what I'm starting to wonder about. In the front end for this project, there's a hash that's created from the bounty description. I've showed this to some of you. We can look at it again. But basically, by taking the text in the bounty description, the ADA amount, and the gimbal amount, you get a unique hash that can be used to verify that the content and rewards of a bounty have not changed. What I'm wondering is, what if we took all of the hashes of the existing, of the written bounties, we placed those in an array in some inline datum that can then be referenced and reviewed by this contract. And we could change the way we think about datum here. And the rule could be that a commitment transaction only validates if it's for one of the bounty hashes that is already in that on-chain data. And inline datum offers us this chance for a treasury issuer, for example, to update that inline datum frequently. So I think there's an interesting system that could be built here that basically, instead of creating tokens to represent uncommitted bounties, we can at least store references to those uncommitted bounties on chain in this new sort of datum and use it in the validation. So I've been playing around with that, and I would love to do a session where we dive deep into what those details might look like. And just wanted to throw that at you so you could kind of carry that around in your head and maybe think about some innovative ideas there. Yeah, how much sense did that make? Mix, what do you think?
Of course, it totally makes sense to me, but again, maybe problem rises. First, this contract become more complicated because each time you have to deserialize the data and then try to match, like try to convert that, serialize that to the type that you have, and then doing some comparison that this is correct or not. So this will add more size and a step execution to this contract, which looks, in my opinion, very clean and very robust. And the second is, if we do not follow that token, again, the question and the problem that we already talked, that how we can identify same UTXO with same inline datum, because it's possible to create that inline datum, and how we can tell to a smart contract to differentiate between this UTXO, which has same datum, and that UTXO, and again, same UTXO. I don't know about that.
That's the key part. Well, the serialization part, because of inline datum, we don't have to worry about serializing and deserializing anymore.
We have to, James. We have to. We have that same in the 0-1 game. You know, in 0-1 game, the datum inside the transaction body is exactly same like this. And since we had to make sure that the datum for next step for playing or redeeming by first player or second player must be exactly this structure of datum. So the person cannot change or cannot submit wrong datum. For that, we had to convert this how can I say, these numbers or this constructor and fields and all these to our very simple datum, and then comparing thing and making the condition. And by doing that, we can tell that a smart contract that this datum is correct or not, because the smart contract doesn't understand this for comparing, at least to my understanding. If you guys know anything better without deserializing the datum, and we can make sure the type and the datum that's going to be in next UTXO is same and it's correct, I would be really glad to hear that.
Yeah, well, so that's exactly why we should play with it. That's, I think there, when I suggest this, what I'm saying is that I really want to explore it, and not that the answers are all there yet. So I think you're making me think this is a good idea to look into this together.
Yeah. But again, I think maybe we have to continue with the so-called estate token or estate NFT, which we used here as a tracking the bounty, and we use it on the game for tracking the correct UTXO for the player's correct game. Still, I don't know any.
So I agreed with you. I agreed with you until I read Quinn's Cogno documentation. This one's really worth looking at, because he really pushed me right here to think about what we might be able to do with some datum versus some state token. So for anybody who's curious about using datum the way that I'm kind of talking about here, I think it's worth reading through the thinking here.
This is the off-chain solution or on-chain?
This, what he provides here is,
You know, by off-chain, on-chain, what I mean, does this tell to a smart contract or on-chain code, the validator, that the smart contract is consuming the correct UTXO or not? So that's the thing that I have concern about. My smart contract knows and understand this is the correct UTXO. Sure, on off-chain we can do a lot of things,
right.
but my smart contract, you know,
This
it's
is,
slow.
well,
Not
so
idiot.
one, no, you're exactly right. So one way to do this is that the datum we're referencing would still have to simply be attached to the treasury UTXO, right? So that would be an easy solution. You say, okay, look, the datum in the treasury right now, it doesn't serve that much purpose. It's a placeholder called withdrawal datum, which just has a pub key hash and a counter in it, right? But it could be a list of hashes that each represents an uncommitted bounty. We could do that. And if that already was the datum for this validator, then in a sense, the work is done, because we're only going to be using the inline datum from the contract UTXO itself.
Were they using a royalty tag to index back in that Congo explanation? Were they using that like a royalty tag for something?
Oh man, if you haven't looked at this, I recommend taking a look. There's, what he's basically doing here is giving you the rails for a lot of possibilities, and it's really, really well done.
I can't wait. Thanks, man.
Yeah. There's a parameterized redeemer.
That's beautiful. That's parameterized.
Levels,
Yeah.
levels. Yeah, I would, a deep dive into this, and I would love to hear people's ideas after you read through here about how you're starting to think about that datum. But just back this withdrawal datum, the other thing that you can do, instead of just keeping a list directly in that datum, maybe this withdrawal datum has, maybe there's a way to reference some other more dynamic UTXO that can be changed, or, you know, yeah, a UTXO, a reference list of datum that can change over time. Mechanism for playing with that, I think it's worth doing that thought experiment. Juan, what do you think?
No, I just wanted to mention that this session has been very helpful to clarify CPI 31, which is the reference inputs. And yeah, I was able to follow it about things great. And
Good,
tomorrow
good.
will be, yeah, tomorrow will be CIP 32, which is inline data, right?
It certainly can be.
But yeah, I mean, what you mentioned, if you wanted to work on attaching data on the script directed to the output
Yep,
instead of the hashes. That's what I understood.
yep.
Good.
Yeah.
Just reporting here.
Also,
And
I think we should somehow explore the difference between embedded datum and inline datum, because embedded, you can see the data on this querying, like
Yeah.
you can see all the words and you don't see like somehow this byte string. I don't know, that would be different or has a different use case embedded rather in inline or.
Oh, you know what? And so look, these ones here are just, yeah, are using embedded data.
Yeah, exactly. Is there any
That's
difference?
because, yeah, we gotta mess with that a little bit. I haven't spent enough time with this to be able to explain it clearly yet. I've done some
Yeah,
experiments that I'm hoping some other people will do too.
Tomorrow we will do it, no problem.
We keep going, yeah.
And I wish I could have the tools. I mean, the situation I have is not good enough to run that session, but I would really love to run that session tomorrow about this. But I hope next week everything will be okay, and so I can continue about the module 2 or 3 videos too, and finishing that topic. But yeah, these are very, I think, critical. I don't know if anyone have the answer, or I don't know, made a video on YouTube or Cardano forum or something. Stack Exchange.
And this one just has the datum hash here instead of the inline datum. So yeah, playing with there's, well,
But there is a value.
well,
This
yeah,
value is the datum, James.
this value,
This is the this is the token.
yeah, you got your love
Is it-
rate and then your policy ID and token
Okay.
name and quantity.
Well, we will explore it tomorrow. No problem.
Keep going with these. Lots of exploration to do. An incredible lack of documentation out there into the community, which means endless opportunity to keep teaching stuff. Yeah, Trevor, thanks for sticking around. Thanks everybody for going a little bit over time today. We'll pick it up same time tomorrow, and I will share a call to action on the course completion token policy once again today. And then we'll go on one of several adventures tomorrow, same time, same place. Oh yeah, and I'll hang on, Dagwell. Yep. See you
Thank
soon,
you, James.
everybody.
Thank you, everyone.
Cheers,
Goodbye.
y'all.
Bye.
Later.
Later,